Hi, in this video we're going to look at how lines in 2 and 3 dimensions intersect with each other, or in some cases don't intersect with each other. Now, to begin with, I'm going to start off with lines in 2 dimensions. Now, in 2 dimensions, we'll say that lines can either be parallel, in which case they do not intersect, or they are not parallel, in which case they do intersect, or they could be a line that's one on top of another. In other words, they intersect all the way along that line. Those are 3 options we have in 2 dimensions. Now, if we deal with 3 dimensions, we have to think in slightly different ways. Lines could be parallel. They could be parallel, or they could be the same line. They could be parallel, or they could be the same line, or they could intersect. Or they could be not parallel and not intersect. They can miss each other in 3 dimensions. So if we think about a box like this, with the edges of the box being lines in 3 dimensions. If we take, for instance, the line AD and the line BF, AD is running along this way, BF is running along that way. Clearly they are not parallel, but also they do not intersect. They cannot intersect. So these are not parallel and they don't intersect. And we have a word for that, and we say that these lines are skew. So skew lines mean lines that do not intersect in 3-dimensional space. So if we have 2 lines, and the vector equations are given as follow, where the lines intersect, those equations are going to be the same. So in other words, I can make this statement here that this equation there is going to equate to this equation there, because there's a point that will satisfy both equations. Now what I can do is I can equate the top lines, because obviously they have to be the same, and I can equate the bottom lines, because they'll also have to be the same. Now I've got 2 equations and 2 unknowns, so I can use simple simultaneous equations to go ahead and solve those 2. So if I rearrange and simplify, I get my 2 equations. And if I go and take equation 1 and double it, and then add the 2 together, or subtract the 2 rather, equation 3 minus equation 2, I'll come up that mu is equal to minus 2. And if I plug that into equation 1, I'll come up that lambda is equal to 3. So the lines will intersect when mu is equal to minus 2 and when lambda is equal to 3. We can check this out by substituting those values into either of the equations. So if I plug it into the first equation, I come up with the point 0.07, or the position vector, 0.07 rather. And if I do that in the second equation, and I plug in the value of minus 2 for mu, I come up with, again, 0.07. So that is the point of intersection of those 2 graphs. Now, once again, I've got 2 lines given by vector equations. And the question is, do they intersect? And we need to explain our answer, whether or not they intersect. Well, if we go through the same process we did before, we equate the x values and form an equation, we equate the y values and form an equation, and then look to solve for mu and lambda. We're going to come up with a situation where the right-hand side over here of the 2 equations are identical, so I end up with 0. And the left-hand sides are not, so I end up with a number. And this means there's no solution. And if there's no solution to this, well, it means that they do not intersect. Now, in 2 dimensions, another way of looking at it are these two lines parallel? Well, the direction vector of the first line is minus 1, 5, while the direction vector of the second line is 2, minus 10. Now, if I go and multiply the direction vector of line 1 by minus 2 rather, I come up with 2, minus 10, which is the direction vector of the second line. So in other words, this direction vector, 2 minus 10 is a multiple of the direction vector minus 1, 5. So the lines are parallel. They do not intersect. We won't deal with that. Now, in 3 dimensions, if the lines do not intersect, it doesn't mean that they necessarily are parallel. They could be skew. Remember, this is the situation we spoke about with that box in the first case. The blue line and the red line, they are parallel. They will be multiples of one another. The blue line and the red line, they clearly intersect. And so you'll be able to find a value for lambda and mu that will satisfy both equations. However, if we take the blue line and the red line, they will not intersect, but they're also not parallel. So we describe them as being skew. They're not parallel, they do not intersect. So how do we go about checking for this? How do we go and check if lines are parallel, intersect, or skew? Well, here's one way. To test if they're parallel, you look at the direction vectors and see if the one is a multiple of the other. And quite clearly we can see that this direction vector here is no ways a multiple of this direction vector over here. So clearly they are not parallel. Now we need to see whether they intersect. So equate the x values, get an equation, equate the y values, get an equation, and then I look to solve them simultaneously. Come up with the value of mu being minus 1, and if I go and sub that into equation 1, I come up with the value of lambda, that is 4. Now, I can check this by putting this into equation 2. If I go and do that, go and put in the value of mu and the value of lambda into that equation, it works. But what happens if I go and try those values out on the z values? So the z values, 2 plus 5 lambda equals 1 minus mu. If I go and make lambda is equal to 4 and mu is equal to minus 1, then my left-hand side is going to come up as being 22. My right-hand side is going to come up as being 2. The two sides are not the same. And so those values of mu and lambda don't work for the final set of coordinates values. And so we can say that these lines do not intersect. In other words, they're skew. So here are some lines we're going to look at and some problems. So we've got 2 equations. Are they skew, parallel, or do they intersect? Well, if we run through these, is minus 1, 4, 2, that direction vector, a multiple of this direction vector here? And hopefully you can see that if I go and multiply this equation here by 3, I'll come up with this equation there. In other words, they're parallel. Are they the same line, in fact? Remember I said when we dealt with vector equations of lines, a vector equation of a line is not unique. So, does this point, the point that lies on line 1, the one that's used to help define line 1, does it lie on line 2? If so, we know that it should be able to make this statement true. If we equate the x's, we get that mu is equal to third. If we equate the y's, we get that mu is equal to sixth, minus a sixth. So the two values of mu are not consistent. And that means that that point 4 minus 1, 3 is not lying on the line R2. So the lines are parallel and they are not the same line. We look at the next example. We've got two lines. We have to decide if they're skew, parallel, or whether they intersect. Well, to start off, if we look at the direction vectors, we can quite clearly see that the one is not a multiple of the other, so clearly they're not parallel. Do they intersect or are they skew? Well, we need to find out whether there is a point that will satisfy both. So I equate my x's, I equate my y's, and I equate my z's. Well, actually, I don't equate my z's. I'm just going to go and try and find out from those two a value for lambda. So we get lambda as minus 7 over 5. That means we can work out mu as being minus 6 over 5. Now we go and test whether those values of lambda work on those two equations. So if we go and plug them in, we get that we get the value of minus 1/5, and we get the value of 11 over 5. And so the two sides are not equal. So in other words, the lines do not intersect. There is no point of intersection. We could also, when we'd come back over here to this step here, we could have gone and equated for z, in which case we would then have three equations. All you have to do then is to equate these two, say 1 and 2, and work out value for lambda and mu, and then go and equate either 1 and 3 or 2 and 3, and see if you come up with the same values for lambda and mu. If you do, then they're consistent. There will be a point of intersection. If they don't, then they're not consistent and there won't be a point of intersection. Right, we got to the end of that, so let's return to the last problem. Decide if these lines are parallel, skew, or they intersect. Well, we can see that they're not parallel because the direction vectors are not the same. So we equate the x values, we come up with an equation. We equate the y values, we come up with an equation. And we get a value for mu at minus 3 and a value for lambda at 2. So if we go and put those values in now, what do we get? On the right hand side, we're going to get minus 1 plus 2. On the left hand side, we're going to have 4 minus 3. And what do you know? 1 is equal to 1. The two sides match each other. So that tells us that we are able to work out a point of intersection. So in other words, those values of lambda that we had will work for both lines. And if we go and equate them, we come up with our point of intersection as being 7, 14, and 1. So that's where the two lines intersect. Right, that's all for this video. We're going to have one more video to look at, and that is how we find the distance of points from lines. So look out for that video. It should be the next one on the list. Goodbye.